So we're now going to work on 7.3, and 7.3 has a lot to it. I'm just going to state that outright. We're working on confidence intervals. We're working on critical values, confidence levels, a lot of stuff. Alright, so I have like different kinds of problems here. We probably won't do them all, but I figured I'd just put them out there and then you can kind of look at them on your own as well. So I am a chart guru. I love them. They make sense to me. It helps keep everything organized. So we're going to have our chart. So N, X bar. We're going to have a standard deviation. We're going to have a confidence level. We're going to have a t-value. We're going to have an error. We're going to have a lower bound. We're going to have an upper bound. We're going to have a z, and we're going to have what happens when we need to find n. We'll probably end up just using this chart for pretty much everything. There's a few cases that we won't use this one. We'll use a z instead. I'm not sure, just reading through these, if we'll need the other one or not. Okay, so reading through this, I'm just looking here at these numbers right here because that's what's important to me. You'll typically know if you need a z or a t based on what the question's asking, so I'll go through it both ways. So your n is 61, it says that right in that problem. Your x bar is 3.0, again that says it right there. Your s is 4.3, your confidence level is 0.9. I'm just changing that to a standard deviation, or to a decimal instead. So last section we had to do this so that we have a positive, so we're just going to do a -1 times something. -1 times, we're looking for a t, so we're going to use t inverse. And then you're going to do, it'll be, oops, I'm making things go crazy here. Give me a second. Let me make sure I'm clicking the right numbers here. Confidence level. Okay. So you're going to do -1 times t inverse. And the nice thing is it'll come up and tell you what you're doing. So you're going to do 1 minus because, 1 minus this because this is to the right, we went to the left. Common degree of freedom. Your degree of freedom is just 1 minus your n, so, or n minus 1, n minus 1. There's your t value. So then your error, sorry, my throat is dying on me here. Interesting. Okay. So your error is going to be your t. Click out here. It's going to be equal to t times, and then you're going to do your standard deviation divided by the square root of your number. Alright, and then you're going to find the lower bound and upper bound. So the lower bound is just your error, your x minus your error, and then the upper bound is x plus the error. So this is going to be equal to x minus the error, and then your upper is just equal to your x plus your error. And the nice thing is you literally just need to fill in certain boxes, and everything else is just going to go for you. So literally you only need those boxes, and everything else is going to calculate itself. So if you're looking for your n, so if by case you don't have an n, and this is what you need to do. So some cases you're going to need to do z. I'm going to put a z. I have the z right here, but I think I'm going to move it here instead, just so that it's kind of concise. And then if you're looking for n, so we're going to put this one over 1, find n. So if you're looking for n, then you'll need to find the z typically. So you'll find the z by doing how we did before. So you're going to do -1 times, -1 times the norm.s inverse and then you're going to use the probability. So it's going to be, remember, when it's alpha sub something, so alpha sub 90, we're going to do 1 minus that, and then it'll give it back to you. And then to find n, you're going to do, it'll typically tell you your error if you need to find an n. So if you're looking for how many people you need to survey, so I'm going to tell you the errors too. Just kind of picking out something that you need. It's not necessarily the right thing. It's not necessarily straight from a question. So basically what you're going to do is you're going to find your n. Sorry, I'm like a little all over the place right now. And it's going to be your z times your standard deviation divided by your error. So finding n, you're going to do equals z times standard deviation divided by your error. I don't know why I said n, because there is no error. Or there is no n. And then you're going to square all of that. So that's what you do first. And then I'm going to put this, oops, wrong thing. I'm going to put this entire thing in parentheses, and you're going to square it. So that's how many minimum you would need for n. Typically, you're going to round up. So you would need 8. The rest of these questions are exactly like this. For this one, you're going to need technology to compute your, you don't even need to compute these values because it tells you what the mean is and the standard deviation, so you don't even need to do that. So you'll just need to construct the confidence interval. If you need a confidence interval given the z-score, typically Pearson will run you through saying, okay, what's your t-value, what's the z-value, so on and so forth. Then you'll do it a little bit differently, and I'm going to show you how to do that right now. It's really easy. It's kind of the same, except, like, it is the same, really. It's going to be the z times your standard deviation divided by the square root of n. So your error is going to be equal to your z-score times standard deviation divided by the square root of n. Make sure these look the same. Oops. Okay, and then same as before, we did your error, your x bar minus your error, doing the same thing here, equals x bar minus the error equals x bar plus your error, and that's how you do it. And then you'll always find n using the z. So now you have literally everything you need. You can just do the problems. I have some in here if you want to try some other ones. So it's up to you. If not, there you go. That's how you do your confidence intervals with normal distributions.